Hello, I'm sorry for the poor video quality. My camera isn't very good, so if I move my hands around a lot, it gets all weird and blurry. I will stop doing that now. But anyway, this is just a quick little video about something I discovered, which AI is apparently terrible at. And as the title of the video suggests, it's calculating the day-night cycle on the Earth. All I asked for was a way to calculate whether some place on the Earth is in daylight or nighttime at some given point in time. And well, I tried 10 different AI or 10 different solutions, 9 AI solutions, and a single solution I made, which is working fine. In fact, I have one working human-made solution, seven failed, seven failed AI solution, and only two working AI solutions. And if you don't want to watch the video with this poor video quality and just want to know which AI models failed and which works, I'll just tell you right now. Meta AI and ChatGPT managed to solve the problem. Not very elegantly. I still think my solution is better, but they did manage to solve the problem. On the other hand, Claude, GitHub Copilot, Google Gemini, Mistral AI, Grok, and DeepSeek all failed some degree of spectacularly. Some failed more spectacularly than others. Mistral. And Microsoft Copilot didn't even try to make a solution, which, yeah, that counts as a failure in my book. But if you want the long explanation, I should probably start by explaining why I need this calculation of the day-night cycle. See, right now I'm trying to develop a strategy game, and this right here is the map I have made for this strategy game. Okay, I know the map looks a little weird to you. You think it's weird that Australia is sideways and South America is a little stretched and pointing the wrong way, but that's because this is not one of the traditional map projections you're used to seeing. This is the Lambert conformal conical projection, which is well different from rectangular projections like the Mercator projection you are more used to seeing. Look, this map projection has a lot of really nice mathematical properties like conformality, which means that local shapes are not distorted. For instance, this is what Socotra Island actually looks like. Its shape has not been distorted, although its area has been distorted. Anyway, I could spend hours talking the map projection. That's not the point of this video. Instead, let's talk about the day-night cycle. That's one thing I want to add to my game eventually. Well, because in-game, I think visual detection ranges should be drastically shorter at nighttime as compared to daytime. Plus, I think it would look really good on the map, and well, we can look at what it looks like right now because I'm recording this after I got the code working. This dark patch you see moving across the map is night time, and the light or transparent parts, the parts without the dark patch, is daytime. And it is working now, but oh boy, did it take a lot of time and a lot of effort to get this working. It was a lot of effort, even though I actually let AI do most of the coding work in this day-night cycle. Yeah, I let AI do a lot of my work. A lot. That's because I am a solo indie developer with huge ambitions for my games. but I'm also working in C++ without using any pre-made engine like, say, Unity. That working in pure C++ gives excellent performance, but it is very slow to work in C++ without any engine. And well, I could make everything I need myself. That's what I used to do before AI tools came about. But then the game would take forever to finish, and that is why I sometimes use AI to automate some simple, well-defined tasks. Stuff like give me a C++ thread pool class, or write a function for calculating longitude and latitude in the Lambert conformal conic projection, or write a function for doing intersection detection. Stuff like that, small, well-defined tasks which I could do myself, but which AI can solve in a matter of seconds. And when I decided I wanted a day-night cycle for my game, I thought this would be another easy case of just write a short prompt and test the results and plug it into the game and watch it work. And here is the prompt I used. You should hopefully see it on the screen right now, unless I have messed something up. You can pause the video to read it if you want. It's basically just me asking for a way of calculating if a point on the Earth is in day or night at a given time in C++, and then I give a bunch more details about how I represent the point and how I represent the time. I'm even kind to the AI, and I say that it's okay if it makes some simplifications. Now, as you can guess from the title of the video, the first AI I tried to solve this with failed. That was Claude, which is my go-to AI tool these days. It failed rather spectacularly. So I did what I normally do when one AI model fails me. I just tried another model, Google Gemini, which failed too. Then I tried DeepSeek. It also failed. Then I gave up and solved the problem myself. It wasn't even that hard. It was two 3D rotations and a single dot product, and that's easy. Well, it's easy if you don't have to do the calculations manually, if you have a computer to do the calculations. But after this, I had become a little intrigued by why these AIs failed, and I was interested in seeing if other AIs would fail this task as well. So I tried a whole bunch of different AI models, that being apart from the ones I already mentioned, Mistral AI, also known as Le Chat, which is the only European built model. Unfortunately, it didn't do very well. I wish it did better. Croc, because I have heard Nazis are really good at math. Meta AI for some reason. GitHub Copilot, Microsoft Copilot, and what was the other one? ChatGPT, that one. And you know what, let's take a look at the solutions. Okay, before we look at the code solutions, I should just mention that 7 out of 9 AIs all agreed that this is indeed a very simple problem. It's a simple vector math problem, and the question can essentially be boiled down to calculating what the vector from the Earth to the Sun is in the reference system of the Earth. Essentially, say we have calculated that the Sun is in this direction, and say we know that the vector from the center of the Earth to the point we are standing at now is this vector. Then are we in daylight or are we at night? Well, to see that, we just need to check if the vectors are pointing in the same direction, and mathematically that's the same as taking the dot product between these two vectors. If the dot product is positive, then they are pointing in the same direction, and the sun should be visible above the horizon. If the dot product is negative, then the sun is not going to be visible above the horizon, and we are on the night side. So a very simple mathematical proposition. The only mildly challenging part about that is that we have to calculate the vector from the Earth to the Sun. And as I said, 7 out of 9 AIs tried to do that and failed. Let's have a look at the code now. Here I have a program with all the different AI solutions. Here you have the solution from Gemini for getting the sun direction vector I talked about. Here I have the solution from DeepSeek, the Chinese AI, ChatGPT, GitHub Copilot, Meta, Grok, yes, the Nazi one, Mistral. Yeah, there are a lot of functions from Mistral. Yeah, that's a whole mess we'll have to talk about. Oh, and here we have my human-made solution, the one I made. And let's start talking about that so you can see how simple this problem actually is. As I said, all we need is the vector from the Earth to the Sun, and this is what this function gets. And the way I do this is, well, I start at midnight, January the 1st. At that point, the Sun is, well, below us. Or at least it's below us if we are at longitude equal to 0. That's why I start with it, the Sun vector being in the minus x direction. But we do have to take account of some rotations. We have to take account of the rotation of the Earth around its own axis every single day. And we do that like this. The Earth rotation angle it goes from 0 to 2 pi, a full rotation every single day. I calculate that from the number of milliseconds we are into the day here. And then there is the tilt of the Earth axis. And well, one way you could mathematically look at this is you could say that every single year the Earth tilt wobbles back and forth, back and forth. That's not true. Astronomers will know that's not true. Actually, it's the Earth which is going around the Sun, and its tilt is staying the same. But from the point of view of the light coming from the Sun, it does appear as if the Earth is wobbling back and forth. And this is what I have right here. I'm rotating around the y-axis with an angle which wobbles back and forth, and it is at the extreme at the summer solstice and the winter solstice. Yeah, this is not a scientifically accurate model, but it gets the work done. And what I've done in this program here is I've actually run every single one of these models for an entire year, and I have plotted a graph which, in my case, with my human-made sun vector function looks like this. This graph here tells us when the model predicts the sun rises and when it predicts the sun sets every single day of every single month. And this is looking exactly as it is supposed to look. We start at January the 1st. We are roughly in the middle of the winter, so the sun sets only around, or rises only around 8 o'clock in the morning, and it sets just before 4 o'clock in the afternoon. Then as we move into spring and then summer, it rises much earlier and sets much later, at least on the northern hemisphere. This is calculated based on London. And going into autumn and winter, the sun starts setting earlier and rising later again. This is good, and the daylight curve looks something like this. This is good. This is what the result is supposed to look like, and this is what I got with my solution. But let's look at some AI solutions. Let's see what sort of graph Claude's solution gets. This is, by the way, my go-to AI tool, and oh god, it's pathetic. the sun only rises once per year, sometime in mid-January, and it sets once per year in mid-July, as far as it seems. And Claude isn't the only one who got a graph which looked like that. DeepSeek has a single sunset and a single sunrise. GitHub Copilot, same deal. Grok, same deal. Let's look at the code to see what has gone wrong. Let's look at the Claude's solution. Claude does a lot of things right. It calculates the time since January the 1st in the year 2000, whatever that's some basic epoch you can use. Yeah, it calculates the number of days. This is the number of milliseconds per day. I recognize that one. And it calculates the mean longitude, the mean anomaly, ecliptic longitude. That's a lot more detailed than I went with my solution. And looks like we have the tilt of the Earth right here, and that's it. Then you just return a direction. You are forgetting about something rather important. Where is the rotation of the Earth every single day? Now, some of you might recognize that what the AI has done is it has returned a vector in Earth-centric coordinates. I think Earth-centric inertial coordinates, ECI. But that's not the correct solution, because I was asking based on a point which, so to speak, follows the Earth rotation around, and this is the wrong coordinate system it's returning in. It's returning in a coordinate system which doesn't take into account the rotation of the Earth, and that's why we are seeing just a single sunset and a single sunrise. Now, yeah, you could probably fix this, salvage this code, but I asked the AI for working code, and I got this thing which doesn't quite work yet. And it's the same problem with most of these AIs. Now, where it gets interesting is when we get to Google Gemini, because it actually has the Earth rotating. That's good. Whatever Google Gemini is doing apart from that isn't very good, but it's good that it has the rotation of the Earth. It even says these are ecliptic coordinates. Okay, that's what they're called. And now we're going to rotate based on how far into the day we are. That's good. That's good rotation angle. You are doing it directly on the elements of the vector. That's fine, that works. You're doing the rotation of the Earth fine, but I don't know what's wrong with this part of the math, but it's not mathing. The sun rises and sets perfectly fine on January the 1st, but then sunset happens later and later and later and later and later and later, and so late that it switches over to the sun only setting the next day. And come midsummer, the sun sets at 7 o'clock in the morning, and it rises again at 2 o'clock in the afternoon. That's wrong. That's just plain wrong. Okay, and then we thankfully have some AIs which did manage to solve the problem correctly. We have ChatGPT produced a solution which produces a plot which looks exactly like my solution. If we compare them, they aren't exactly the same. I think probably ChatGPT's solution is a little bit better than my solution. I was making some quite heavy approximations, but for the purposes of a computer game, this are basically both correct solutions. And the Meta AI produced a different but very similar correct solution. we can take a look at what Meta AI has done, because Meta has included some nice comments in the code. Chat GPT didn't do that. What's Meta doing? Well, they are calculating the Julian calendar. That's what's used in astronomy, so I guess it makes sense to use the Julian calendar. Then it's calculating the mean longitude, the anomaly, but they aren't using the anomaly, so why even calculate it? Weird. Okay, it's making some approximations, but and throwing it away, but why did you calculate it in the first place if you aren't going to use it? And then you do remember the rotation of the Earth. That's fine. This is fine. I will include this project in a link in the description, so you can look at all the AI code if you feel like it. So okay, we have 2 working AI solutions, but I've saved the worst for last. Mistral, also known as Le Chat, the only European AI company. What is this? The sun rises at 2 o'clock in the afternoon, and it's set, and it set around midnight, and then it what was you thinking? Let's look at the code. Mistral, oh, you have a lot of functions. You what do? Okay, you have an isDaylight function. Mistral is the only one which didn't realize that this was a simple problem of calculating the vector from the Earth to the Sun. It tries a different solution. Okay, what are you doing? You're doing a Julian calendar. That's fine, because we're doing astronomy. That's fine. Then you're calculating the position of the Earth in the sky, the declination and right ascension. Now, I'm not an astronomer, so I'm not entirely sure I understand what that is, but it's sort of astronomy sounding terms, and you calculate the longitude and latitude, but I calculated this point from longitude and latitude because I thought it would be easier to work with a 3D point, and now you're calculating longitude and latitude back. And okay, local hour angle, I get that we can calculate longitude and latitude by looking at the watch. I guess it's trying to do the reverse, calculate the time, the local time based on the longitude and latitude. Yeah, it's doing a bunch of constants, doing a polynomial equation, it seems, and then it's doing a bunch of trigonometry. I have no idea what it was trying to do, and it certainly didn't work. Yikes. Oh yeah, and there was one more AI I asked. I asked Microsoft Copilot, and it refused to answer. Or instead of answering with a C++ function, it told me to use a third-party scientific library, which I guess would solve the problem, but that's not what I asked for, so that counts as a failure as well. So now you have seen all these weird and usually failed AI solutions. So, what can we conclude from this? Not much, honestly. It was just a short little fun video about something I discovered when working with AIs. But if there is anything to conclude, it is that most AIs are pretty bad at 3D geometry, while a human like myself have a relatively easy time with 3D geometry. And if there is a lesson for you to take away, it is that you should always check AI-generated code, actually run test on it, see if it actually works. But honestly, this video was just, as I said, a fun little comparison of 9 different AIs. Okay, this is it for the video. You can go now. And while you are going, feel free to click any of those random buttons down there. They don't do anything, but maybe it's fun to click them. You can go now. Okay. You can go now. Okay, fine. I'll have to shut off the recording for you to go away then. Okay, I'll do that now.